It's my pleasure to introduce today Joshua Rosenkrantz. I had the pleasure to work with Joshua. He was my former MASC student, and Josh graduated from Western in 2014, and then he got his master in 2017. And he worked on a problem involving fluid structural interaction of light frame timber houses. So he did very good work and very impressive experiments at Windy. And he has been working in industry since he finished his master degree at Western. And today he will be talking about his experience in engineering consulting at both large traditional and structural engineering companies, as well as at smaller organizations, which has a broader focus. His talk, he will cover a few examples about the project that he has been working on and illustrating the roles that his role in those projects and in the day-to-day operation. So Josh worked in 2017 in a company called Thornton Tomasetti, where he has done structural design for medium-rise buildings and industrial complexes, and he did many projects. As you can see from the bio that he was circulated. And then after that, he joined another company called Carson Dunlop Weldon Associate in 2021, working as a project engineer, where he was involved, or he's currently involved in project management practice. I think this is very interesting to hear about Josh's experience. It's good to bring somebody who is closer in age to the graduate students. Then you don't hear always the story of senior people like us. Probably you cannot relate to that closely, but I'm sure you're going to relate very well with Josh's experience. So Josh, the floor is yours now to start your presentation.
Fantastic. Thank you so much for that, Dr. Ashraf. That's really appreciated. I'm just going to go ahead here and share my screen. Just a moment here. Sorry, I'm having a little difficulty finding the, oh, there it is. Got it. Excuse me. Big button. Perfect. Okay. So, what's that? Perfect. Thank you so much, Dr. Eldamadi. So my presentation is engineering consulting, the first 5 years of my career. This is just a bit of a recap to what Dr. Ashraf just told everybody, but I'll just go through it really quickly again. So in 2017, I graduated with my MASC from Western Engineering. Dr. Ashraf, it was my supervisor. I had the pleasure of working with him. Really knowledgeable, and I was in great hands throughout my graduate degree. Then after that, I went to start working for Thornton Tomasetti, and this was really my first experience in consulting engineering. I worked there for 4 years, finishing as a project engineer. So at the end, I was basically managing my own small projects. I was involved in, I had the opportunity to be involved in a lot of different projects, primarily in residential and institutional work, but across all different material types, height, sizes, uses. It was a really good foray into consulting engineering. As of 6 months ago, I just switched over to CDW engineering, and I'm working with actually another UWO alum to lead the project management practice. So I kind of wanted some more experience in running my own project start to finish with PM, but I also wanted to keep doing structural engineering. So at CDW, I've been able to do that and get out of the more traditional structural consulting role. But I'm going to talk to you guys today about what I've done in the 5 years of being in industry. You're all in grad school now, but if anyone wants to do consulting engineering after that, this is kind of the presentation for them. It's kind of the presentation that I wish I had just to kind of give you a taste of what it's going to be like if you end up choosing this career path. So I was giving this presentation to my girlfriend last night, practicing it. Thank God she is so patient with me. And she was like, you need to add some photos that aren't about this to make you seem more personable. So during the pandemic, I got really into making Turkish breakfasts and unsuccessfully trying to walk my cat. So other than my CV, those are my two fun things. To move on, why is the presentation called engineering consulting, the engineering in brackets and consulting? And it's because in the first kind of years where I was doing the job, I had a bunch of other friends who were doing management consulting, and I noticed that there were like a lot of similarities between my job and theirs. Yes, it was fundamentally different. I'm doing structural engineering, and they are helping a business, trying to get out of the weeds. But for three reasons, I felt they were so similar, and it really resonated with me, and it helped to explain the business really well to me. So for the first reason they're similar is the organizational structure. Mid-sized structural engineering firms often look like mid-sized consultancies or large consultancies. They're partnerships that form these silos and these chains of command, from managing partners to associates, VPs, and then project engineers who might manage one or two green engineers. And that's the way work gets done and projects get completed in these kind of vertical silos. Next reason is that you're doing project-based work. There's a start, there's a middle and an end to it. And there's the deadlines and desired outcomes. And while there's often not really contracts, and I know this might be a little bit different from management consultancy because sometimes there's contracts, but every job is pretty much new. Yeah, you can work with a developer on more than one job, and yeah, maybe the projects are similar, but they're definitely not going to be the same from project to project. There's always new challenges. And lastly, reason why I like to call it consulting for consulting is because you're being a consultant. You're being consulted as an expert. You are the foremost authority in this field when you sit down at a table at a coordination meeting, whether you're at a kickoff. People are looking to you to have this knowledge set that nobody else has. So before I extol its virtues, I got to put out a little bit of a warning. It's not for everyone. There are some challenges. And the first one is that it's really tough at first. There's a big learning curve. I mean, you're trying to become an expert in the field. And though school, I would say, in this field kind of uniquely prepares you really, really well for the industry, there's a whole building code to learn. There's all of these codes and manuals and software and business, and there's so many things to learn, and to kind of look at it at first kind of uphill it can seem quite daunting. There's a bit of an expression in the construction industry, and I put it in quotations. It's the poop rolls downhill. You're in a client-facing job, and your clients are also in a client-facing job, and their clients are also in a client-facing job. So you can see how, when you're the client of a client of a client, if that client at the top of the chain has an issue, well, you better bet that you do too. And you better bet that you're going to be kind of at their whim, and their deadlines are your deadlines. So there's a bit of pressure that way. And finally, I'd say that liability is much greater than what you're paid. Now, that's why you have insurance But there are so many details that go into every drawing set, every job that you do. And even small mistakes can have really large consequences. And so that's why it's really important to have a good QA, QC mechanism at your organization, so you can sleep at night. That said, it's really not all bad. And one of the first and foremost reasons is that you learn this profession. And in an era where work can be kind of unstable across many different industries, you are going to be employable because you know this profession, and it can take you all around the world. If you just get a few more designations, say you go and get your CEng, now you're good in most of the Commonwealth, or your ISTRP, for example. If you learn, all you have to do is go to a new place, learn the building codes, but that's it. The engineering fundamentals are always there, and honestly, most of the software is the same. Second reason is that you're an expert, and there's a lot of pride to be taken in that. When you sit down at a meeting and you are consulted as an expert and people are looking to you, it feels good because you know something that's valuable and people are looking to you for your advice. And lastly, there's a bit of a job satisfaction. So I get this. I did the U of T Schwartz Verizon Center. It's on College, just at Queen's Park, and that ends up being right on my commute home every single day. So every day I bike by it, I see it going up, and I take a little bit of pride in knowing that, there's going to be such a great impact on the local community there. And I'm curious and excited to see how the local community interacts with the building, comes in and out of it, and what goes on there. And to know that you had that kind of impact or effect is really satisfying. So this presentation is kind of about the day-to-day as a structural engineer, consulting engineer. And it's really hard to talk about that without talking about the project lifecycle. So at any given time, depending on what you're doing, you're going to have multiple projects on the go. And knowing where they are in their design lifecycle is going to dictate what you do that day. So projects in the design phase are going to take up most of your time when they're in that phase. But projects in the construction administration phase won't take hopefully as much of your time, but you'll have more projects there at any given time just because the construction of buildings usually takes longer than their design. That said, let's go through and just talk a little bit about what's in the design phase. So you have a pre-design, which structural engineers often aren't really involved in. It's more architectural, or the design architect gets involved there. But we're brought on typically at the schematic design or design development phase. And at these phases, you get a rudimentary set of architectural drawings, and you're trying to fit structure to it. And you might have at any one of these deadlines, like a design set that kind of looks like a building, but there's just like an amorphous column and slab, and maybe you put in a transfer structure here, and yeah, maybe the building looks right, but there's not much to it. And as you progress through, design development, maybe you add more rebar to your drawings. You're starting to put beam sizes down. You're starting to fill out details and sections. Maybe you add some general notes. And then by the time they get to construction drawings that you want to submit for a building permit, that's when you have, your general notes, your typical details, your plans, your sections, reinforcement, everything is on these drawings. And now they look like a real set of drawings. Then they go out to be priced. So this is when there's a bit of a lull in the project. And either they go to a cost consultant if they're an owner-led job, or if the expected cost is probably going to be okay, they go right to the tendering phase and we'll see what contractors actually bid on it. And if the price is right, then we'll start construction. But if not, then we'll go right back to either design development or construction documents. And we'll try to do some value engineering exercises in that realm. So now that we know about the project life cycle, before I move on, there's some terms we're going to talk about. They're kind of designing in parallel and designing in series. And when I say those two terms, designing in parallel means that every single consultant, architect, everybody on board is designing the project at the same phase. So the shoring engineer and the structural engineer and the mechanical engineer, everybody, when they're in design development, everybody's in design development. And when they're kind of producing construction documents, everybody's producing construction documents. Designing in series, and sorry, designing in parallel, that allows for a lot more coordination. So the reason you're doing it all at the same time is so that you can hash out all of your design conflicts all at once. When I say designing in series, that means like one consultant is producing a design and then feeding it to another consultant and feeding it to another consultant so that they're kind of done separately. So say, the design architect produces their drawings and then feeds it to the architect of record and the structural engineer, and then we'll feed those to either the shoring engineer or vice versa. And so all of these design steps are happening at different phases. So now I'm going to talk to you about project organizations, because once we have a sense of the project lifecycle, the other thing that's going to dictate your day and what you do is by understanding the project organization so that you can answer these three questions. Do you know who your client is? What are their goals? And are you acting in their best interest? So at any given point, you're going to have, like we said, like a bunch of projects going on in your day-to-day, and you need to be able to prioritize based on deadlines, but also what are you doing and is it in the client's best interest? So as we go on, we'll see that there's at least the two different project organizations that I've been involved in. Our clients are different people. And so we need to know, am I throwing my client under the bus, or am I making them look good? And you always want to make them look good. And that's going to affect, how you present documents, how you figure out problems, all the way down to how you word your emails and who you're sending them to. So the first project organization we're going to talk about is the residential or developer-led project. And this is for projects typical of like condos. So at the top level, you have a developer or say a consortium of developers, depending on how big the project is. And you'll also have lenders. Those will be kind of at the same echelon. And directly contracted to the developer are all these different entities. So you have the structural consultant, the architect, the MEP, the mechanical, electrical, and plumbing consultant, and the civil consultant, and potentially a few more, the geotechnical, whatever. So your relationship, your client is directly the developer. So altogether you produce your design, and then it'll get tendered, and then the GC will be brought on board, direct relationship with the developer, and they will act as the prime. So a couple things is that one, in the project organizations I'm going to show you, these are always design, bid, build projects. I don't have too much experience with design build projects or P3 projects. These are more for larger infrastructure. If you're doing hospitals or if you're doing transportation infrastructure, stuff with the government, those are kind of the project organizations you'll be using. But in like the architectural engineering community, these are the ones, the design bid build process, and the project organizations that I'm going to show are the ones that are honestly like 90% of your work. In this example, I've highlighted the GC, and that's because they're acting as the prime, or they're acting as the quarterback for all of the documents that go on in construction. So if we go back and talk about the project lifecycle, like I was saying, the design documentation phase will take up the majority of the time, but it's not as long as the construction phase. But what goes on in the construction phase is almost as complicated. You have all of these documents going back and forth. You have design changes, number one, which are changes to the design documentation that you created in the design and documentation phase. But Not only that, you have all the GC subs coming up with their own drawings called shop drawings, which are interpretations of the design drawings. So you need to take those drawings and make sure that they are in line and not conflicting with the design drawings. So it's a lot of documentation, both in changes and these shop drawing reviews and going back and forth, site reports, all this stuff. And that all gets quarterbacked in this organization through the GC. So there's a few characteristics about this organization. One is that schedule is usually prioritized over cost. I put an asterisk there because cost is still very important. But the reason why schedule is often higher priority on these jobs is because idle property burns a hole in a developer's pocket. You have your ongoing cost of capital. These projects require huge capital loans. And so, you lose an interest on it. There's taxes, there's mobilization costs every month that the GC is on site is another huge cost just to keep them there. And in certain projects, depending on how you're doing your shoring and what your water table is like and how deep you're going, there could be substantial dewatering costs. This is just an example of some types of costs, but it's costly to just sit and not do anything. The design development for these projects is usually coincident with early construction. So, a lot of these jobs can be designed while excavation is ongoing. And like we were talking about before, these projects are often designed in series. So, for example, the shoring engineer might get involved very early, design shoring when the, area of the parking garage is like loosely defined. And then once that design is set in stone, now the architect and the engineer have to come up with a way to like build within those confines of the shoring in that one particular area. So an example of one type of project I've done with Thornton Tomasetti is the West Onlands Block 8 towers. So those are towers A, B, and C from closest to farthest. This is literally just the east of the Distillery District in Toronto, if you're ever down there. And this project was designed to be just rental units. The Ontario government basically had a scheme where they kind of sold the rights to development to developers so long as they built rental units. And this was a huge reason as to why the developers, wanted a tight schedule kept, because, every month you don't have these towers up, that's a month of direct rent gone. So this design was performed in series, which created a lot of challenges. So the design architect was brought on quite early, I don't know if anyone knows Kobe of Denmark. They created this design and they kind of promised this to the developers and then more or less washed their hands of the project and said, okay, architect of record and structural engineer, figure this out. So that was really difficult. And it presented a lot of challenges. Architecturally, walls had to be put here, but walls couldn't go there. And, at the end of the day, we had something like 4 or 5 transfer floors in each structure. And you can appreciate how complicated that gets. The design development and the construction document phases for this project were basically done while excavation was ongoing. We were in DD when they put shovels in the ground, and we were getting permits basically when excavation was complete. So there's your timeline. And that took, like I was saying, probably 80% of my day during the design development phase. And, during construction administration, it was quite a lengthy process too, quite involved, because the design wasn't as flushed out in the design development phase. So there was lots of construction issues and mechanical conflicting with structural, but we figured it out and the buildings got built. So the next project organization I'm going to talk about is the institutional owner-led project. So this is typical of like universities. I did a project in Stratford for the Stratford Theatre Company, stuff like that. So where you have an owner, the owner typically sources most of the project costs themselves. Maybe they'll get a loan, maybe they won't. And they typically have a relationship directly with the architect. And that means that here, the architect is your client if you're the structural consultant. And this will be the way things are. The architect will produce, you know, a whole comprehensive set of drawings. They will be the prime, meaning that when this job goes to construction, all of the change and shop drawing related document transfer goes through the architect. So it's quite a bit of complication, and correspondingly, there's an added fee for the architect to do this. And the GC is just the general contractor in this job. So some characteristics about this project organization is that cost sometimes takes priority over schedule, schedule sometimes over cost, but it really depends. You know, in some instances, if you have a donation and that has to be the project budget, then, you know, you're very, very constrained. But it, you know, might make sense to spend a little more money if you're, say, a university and you want to get the new building done in time for fall semester, or if you're a sports organization, the stadium's got to be done for the start of season. So those types of factors can have a large influence. These projects are usually designed in parallel, so they take a lot more time to design, but at every step of the way, like we were saying, all consultants are involved at the same design phase. And what that means is that, you know, there's a huge amount of coordination before you can be complete with any deadline. So when you move to the next phase, certain things have to be coordinated. And I don't know if anyone's familiar with like Revit or BIM, but BIM 360, their cloud-based tool, is really, really important for stuff like this, because it allows you to just kind of see everything all together and everyone's submissions in 3 dimensions. I think these are the most fun types of projects, honestly. The uses are so varied, the differences in material. You know, I like condos. I think they're pretty cool, and I like being able to know how to design them. But when you talk about like an institutional building, they always have the most unique features and uses, and I think that is really neat. And the way the public engages with them is always so different. So for that reason, I truly like these types of projects. Example of this one is one of the buildings I was talking about earlier, the U of T SRIC, which is supposed to be U of T's kind of response to Mars, which is across the street. So this is on the northeast corner of Queen's Park, or University and College in Toronto. So the university for this one received a huge donation, but that was really all they had to go on for budget. So this thing, you know, made it to the cost consultant, say 3 times, and sent right back into design development, where it was fundamentally redesigned like 3 times to try to strip out absolutely everything that was completely unnecessary. It was so a lot of time was spent in the design development phase, and the design involved all parties at all times. So it was designed in parallel, like you're saying. The design architects, this is crazy. The design architects were at like every meeting, well into construction, which is unheard of. These guys would fly up from like New York on like a bi-weekly basis just to go to these things. So as a result, you know, this project spent a lot longer in design development and construction document phases than in construction administration when we were actually building it. And that worked fine for the university. You know, they were happy. They had 2 buildings that were completely functional before, so they could be functional for another couple of years while this thing, you know, went through all of the value engineering phases. So now I'm going to talk about what I do at my current job, what I've been doing for the last 6 months. And this is the so it's small commercial and rehabilitation. So what we do is we act as kind of, we are both project manager and structural consultant directly to the owner. The owner is typically someone we know through our physical condition assessment wing of our business. And they say either we have an issue with our building or we would like to make a small renovation or something. And we're brought on board to both do the design, but then also to tender the job out, to administer the contract, and then also to do the construction administration. So typically we work just us, or we have a sub-consultant, somebody like a geotechnical engineer or a mechanical engineer. And then we will work with the owner to tender the job out to a general contractor and themselves. An example, some of the features of this type of project organization is that it's almost invariably cost over schedule. Structural is like we were saying, structural is the prime consultant, and we contract other disciplines as we require. The prime consultant is, like we were saying again, we're not just responsible for CA, but we're responsible for the entire thing start to finish, be that construction document preparation, pulling building permits, tendering the job, and then overseeing construction administration and administering the contract. Jobs are almost always cost controlled so long as operation limitations can be avoided. That's as simple as it sounds. If, a lot of times we have a client that wants a job done because it is either maintenance or preventative maintenance, but as long as it's not really affecting the use of their building, they would rather try to reduce costs as much as possible and draw out the construction process. It's everything to save a dollar if it helps. So an example project, like a small rehab project that we were doing. So this is a 5-story apartment block in St. Catharines. Experienced some differential settlement at this corner, about 3 inches, substantial. Here you can see our geotechnical consultant we had out to provide some settlement and slope stability analysis. On this one, we worked directly for a client that we've worked with a lot on. We help them with jobs they have in a bunch of apartment buildings they manage. And we will prepare the contract documents for these, the construction documents, and tender this job out ourselves, as well as pull the building permit and perform any site visits that are required. And in this job, the schedule wasn't a huge priority because the residents could stay comfortably in their units. So we've talked about the design life cycle. We've talked about the project organizations, a few of them at least that come up all the time in architectural engineering consulting jobs. And now I kind of want to switch over to something that if anyone's considering this career path, these are some lessons that I sat down and really thought about these because there's something I wish I learned or had known earlier on. So I'm sharing them with you now. But if you want to do this, these are kind of great points. So in the soft skills department, this is funny. My old boss used to get this all the time from his drafter when he was a young engineer. And he would come to him like, I don't know, 4:30 p.m. on a Friday being like, I desperately need something drafted. Can you please help me? And his response would be, poor planning on your part does not constitute an emergency on mine. I know, it's really tough. It's savage. But the solution is to just suck it up and get good at time estimation. This is one of these like all important skills that you're going to use forever and ever and ever in engineering consulting. And you need it to be a good manager. You need to be able to understand how long it's going to take you or someone equivalent to you to do a particular task. And the better you get at that, the less you're going to be freaking out over deadlines, the less you are going to be panicked about getting stuff done, and the more surety you're going to have when you walk in, you say, okay, perfect, I know exactly what needs to be done. And that comes with doing the task a few times too. So I wouldn't get all bent out of shape at the beginning if you're finding things are taking you 3 times longer than you estimated, but getting good at that skill is very important. The other, other end of that solution, collecting favors, it's not supposed to be nefarious, but it's just supposed to say, hey, you're going to be working with a lot of people both in your organization and outside your organization, and the more you can scratch their back and be a nice person, go a little above and beyond for them, it will be noticed. And when you need something from them, either can you review this document really quickly, can you help me out with this, can you just see if you could put this lower in your queue to help me, they'll be much more accommodating. sorry. The other thing is to track your own progress. So what we started doing at Thornton Tomasetti early on was, every year we'd have this like skill matrix, and it would be, it was so thorough, and I think you can find these online, but to go and look up like every major skill a structural engineer needs, all the way from like, performance-based design seismic stuff to like, have you ever designed aluminum? And like, it ran the whole gamut. And of course, when you start out as a young engineer, you're going to be like, I know how to design some concrete beams, and I know how to design some steel stuff. And you might not fill everything out, but at least you know where you have some skills and where, you should start putting up your hand for jobs that involve other skills that you don't really have at this point. And it's okay to be a little more junior, right? Like if you're going to have to work with a colleague who's done this and feel a little more junior, that's fine, because you're gonna build these skills, and the more you keep putting your hands up and the more you keep filling out the sheet, the more, well, better you're going to be at your job, the more employable you're going to be. But you're also going to have this like nothing takes you by surprise kind of thing, and that is super important to you growing as a young engineer. Lastly, I'll say good phone presence goes a long way. This, you can take people out for as many business dinners and go play golf with them. I mean, that's not really done anymore, but I don't know. But you can do all these things that are considered classic business development, or you could just have a really good attitude when you pick up the phone and just say, hey, and how you doing, and have a little bit of banter and chat with them. Maybe, how's their family doing, or maybe you remember, I don't know, some funny thing that you guys did on site that one time, and that goes so long in leaving a good impression of yourself with other people. And the next time, say an architect you work with has a small job and they go, I'd rather work with my friend. I'd rather work with this person because we just had this great relationship, or it felt like a great relationship over the phone. So, flipping over to, there we go. Some valuable lessons with technical skills. Always do your own drafting when given the opportunity, really. And if there's like assignments where you get early on in your career and you could either do a little more design or you could draft your own design, take the drafting. It's such a fundamental skill to be able to communicate via drawing, whether it be with someone on site, you're trying to get your idea across, with a client, you're in a coordination meeting, you need to know how to draw. You need to know how to draw. It's the universal language of structure and architecture. And ideas just cannot be communicated with written word as efficiently as they can through drawing. I've recommended a book here, Manual of Section by David J. Lewis and a few others. This, first of all, it's a fantastic book. Visually, it's fantastic, but it also teaches you like the importance of section, the importance of drawing convention, and how to present things meaningfully. At the end of the day, drawings are your product. It's what you give to someone else in exchange for money, right? And it needs to be good, because that's what's going to differentiate you. I can't say this enough, again, you guys are all in grad school, and I'm sure those in structure are using finite element analysis products all the time, but get super familiar with finite element analysis. It's something that I got familiar, or I had the opportunity to get familiar with while at grad school, and I found it to be super useful in SAP. So there you go. And it's important that like what everything does, and just like how to think in finite element. Like if there's a problem that can be solved, and you just want to do a real dirt simple model that you can just like make them so quickly, it'll really serve you. For this, I've recommended a book, Modeling for Structural Analysis, Behavior and Basics by Graham Powell. He's was, I think, a professor emeritus at UC Berkeley. He was one of the founding people at CSI. And this book will take you all the way from like, the simplest beam elements all the way to crazy nonlinear hooks and tell you all of the different like elements, but then also tell you how to teach you the importance of like qualitatively, like why certain analyses are done, nonlinear time history analysis, all of these things. It covers everything. So it's really comprehensive. And I'll leave you with this last point. It's always start simple. Like more than half of everything that comes across your desk can be solved with a little back of the napkin calculation. And to do anything more is just to spin your wheels and waste your time. And you really have to understand where detailed analysis is required and when it's not. And and this might resonate with a lot of people in graduate school, because what you do in graduate school is really detailed. It's you're really trying to solve these very complex problems. And if you're in grad school and you're working on something, believe me, it's a complex problem. But when you're out there applying, doing applied science in the workplace, often the wheel has already been invented for you, and there's no need to go and recreate it. That said, some problems are really complicated, and it is good to know when that level of analysis is required, and to know that you do have those skills being a grad student. But that said, knowing when it's required and when it's not required, hugely important. I hope this has been informative. I'm going to leave it on this note, but I've really enjoyed my first 5 years in this business. Here's a picture I've been, of something that, so this was a stair. This is like one of my first engineering assignments. And I remember my boss putting this on my desk and saying, "Can you help me out with this?" And it's a floating switchback stair. And oh my God, did this give me so many issues. It was just so complicated. There you can see it under construction. And I remember putting a lot of hours in figuring out why it wasn't doing it. And there was a lot of design challenges, like the long-term deflection was going crazy on this thing, but how do we solve it? And you know what? You stuck with it. It was a long night, but here's the architect and I standing on it when there was no vibration, no nothing. It felt so good. It felt great. So anyways, that's kind of it. If you guys have any questions, let me know.
Thank you very much, Josh. Maybe you can stop the sharing, then we can see the hands when somebody raises hand.
Sure, perfect.
Okay, and you can put also your questions in the chat.
Okay.
Okay, let's check the chat now.
I think Prashant has his hand up.
Yes, go ahead.
Hey, first, thank you for the presentation. That was very informative.
Hey, no worries.
Yeah, my question is, do you need a PN for specific parts of the project lifecycle? Is it just mainly for stamping the drawings?
So that's actually a really good question. Honestly, unless it depends on your organization. So my organization right now, I'm one of 2 structural engineers here. So yeah, I really need it because on the drawings that go out, I need to stamp those drawings. And I need to stamp reports and letters and all that stuff. At my previous company, Thornton Tomasetti, for example, we were all PNGs for the most part, but only the managing principal for our office was allowed to stamp drawings, and that was something they'd agreed upon with the insurance provider. And so what that meant was that, like I was a project engineer at the end, and my really good friend, Colin Brennan, was this Irish guy who, he was also a project engineer, but he wasn't a PN because he had just come from Ireland. That said, he knew how to do the job, and he learned the building codes. It was fine. He just, hadn't gotten his PN. I think now he has it, but it's not exactly necessary. And obviously, when you start out as a green engineer at one of these companies, you're not going to have your PN. You're going to be in EIT. So it's something you get eventually, but if you're going to be offering services to the public, obviously you need it. If you're going to be working as part of a company, you may not need it.
Okay, thanks. I also have a follow-up question, if you don't mind.
Sure.
Do you ever plan to start your own investment, and do you feel like you have the expertise to back up the drawings and all the processes of bidding and the project lifecycle with your knowledge?
Yeah, for sure. I mean, like obviously, when I switched to CDW, I switched because I felt I had a pretty decent rudimentary understanding of structural engineering. And so I felt comfortable enough that when I started talking to Richard Weldon over here about moving, he was like, we needed structural engineers capable of doing this, this, and this. Obviously, I'm not capable of doing everything. It takes someone who's been a professional engineer for many, many, many years to be comfortable with doing, some groundbreaking stuff. But for smaller projects, as long as you're working within your wheelhouse and as long as you understand everything that you're doing, there's no issue with you stamping and sealing something. It goes back to that like PEO guideline stuff, like it's within your competency. So as long as you're acting within your competency, yeah, there's no problem. And for me, doing what I do now, totally.
Thank you.
Yeah, no problem. I think we had Mitch.
I see Mitch, yeah.
Yeah, I actually was kind of going to ask the same question as Prashant with his follow-up, just like if you'd ever think about a sole consultancy kind of with, and if so, like, would you consider yourself to be in a good place having, a master's, having experience with codes, having learned the soft skills of self-management and things like that? If it is kind of something you've thought about, like, is there any recommendations for us? Like, I'm in the geotech stream, but I've thought about the sole consultancy route. Is there any additional, I guess, recommendations you'd have?
Yeah, so if you want to go in the sole consultancy route, it tends, you can, and I don't know about geotechnical engineering so much. I've had a couple conversations with some geotechs about it, but you typically want to go and work for a consultancy, an engineering firm for a little bit, just to understand all the business, the little tiny business mechanism nuances, billing and business development and project tracking. You just pick up on things that are kind of important in the day-to-day. And then you also have contacts, right? So it's tough to just go into doing something like that and to hang your hat out there and say, hey, I'm doing this work, and not really know anybody in construction. But if you have, maybe one or two contacts from jobs that you've done in the past where you've worked for some other firm, then it's just a little bit easier.
Yeah, that's one thing I've heard from other people in the sole route, that you really want to have connections, kind of have a niche that you can fit into well. So
yeah, and you'll learn what your niche is by working a little bit oftentimes too, right? So like, and I would say, like, for me, there was no way I could have gone to CDW without having gone to TT first and worked at TT first to like get that knowledge base. So
okay, yeah. Let's see, Magai.
Yeah, my question was, how much of an expectation is there as a starting MASC or MH?
It's a good question. And it's been 5 years since I was starting, but I think typical salaries are like maybe 70, around about 70, 75. Now, here's the thing too, and it goes back to Mitch's follow-up question, I think, and it was about like, how much does the MASC help? And I personally, when I started working at Thornton Tomasetti, they had a policy where they would only hire people with masters. So, I mean, I don't think I would have gotten my shoe into that door had it not been for my graduate degree. So it's kind of, it's good in that regard that, it might increase your salary, but sometimes it might, it might help you get in the door, period. So.
Okay, we can take a question from Philip.
Yeah, hi, I just want to thank you again for the presentation. A question that I had was, I know people do, like, there's MEng and then there's MASC. from your experience or from your experience working, is there any preference over one or the other? Are they like basically the same? You just go in and.
It depends. So if you're working at an engineering consulting firm, like a straight up structural AEC firm, there's typically not too much of a preference, but I know, for example, Thornton Tomasetti in like 2008 or something acquired a company called Weidlinger that makes up like half of the firm. And that company does stuff with blast, it does defensive design, it does some fluid mechanics design, it produces building dampers, for example. And I know that company, because of its specialty, it definitely prefers candidates with research-based master's degrees or graduate degrees.
Okay, thank you.
Okay. Any other question? I see Phil, your hand is still up? Okay, so I'd like to say some closing remarks. I was very proud of you, Josh, for the presentation. Thank you very much.
Thank you so much, Dr. Ashraf. It means a lot.
Really, really excellent. I know you are a good presenter, and I believe you won before the civil seminar presentation, right? I recall.
He remembers, yeah. Thank you.
But even your presentation skills are becoming even higher and higher now.
Thank you. I very much appreciate the compliment.
Yeah, and I realize I think it was very beneficial for the students. I think we should do that more to bring people probably at your stage close enough to the students in terms of age and also experience, but at the same time you have enough experience 4 or 5 years to be able to reflect on it.
I had early on in my I spent a summer at Sigmund Sudak, and there was always this senior engineer who said it really takes 5 years as a structural engineer to figure out whether you like it and to really kind of start to get to know it. And so now I'm at that mark. You're right, and it's nice to be able to comment on it.
5 years, I think it's right. Good duration to develop a good expertise in a certain field. Yeah.
Exactly.
So again, thank you very much, and I'm hoping next year we'll bring you in person.
I would love to come in person.
Yeah. So if we are in person next year, we're gonna definitely invite you.
Awesome. Great.
Okay. Great. Thank you very much. Thank you
all.
all.
Right.
And see you next week.
Bye-bye. Ciao, everybody.